Let's do one final comparison between vertex form and intercept form of a quadratic equation. So what I've done here is I've listed a number of criteria that we're going to use to compare and contrast these two forms. I've got vertex form listed in red and intercept form in blue so we can see them all side by side. So first of all, a general equation listed here and here. These would be given to you on a summative assessment. By now you might have memorized them already anyway, just through your practice, but those would be given to you. Now, being given to you is great, but you have to know what they all stand for, and that's the intention that we are going to work through in the next little bit. I've just created an example of a quadratic equation that would fit each of these forms. Here's one in vertex and here's one in intercept, so we can make some direct comparisons. So when we are given an equation in vertex form, what do we know about that parabola directly? Meaning just by inspection, by looking at this equation. Well, if we read it from left to right, we know that this A value can tell us two things about the parabola. It can tell us if it is upward or downward facing, depending on its sign, if it's positive or if it's negative. Its value will tell us whether it has a stretch or a compression factor compared to y equals x squared. And that matters because the value of a in y equals x squared is 1. We want to know if it is a narrower parabola or a wider parabola based on that as a baseline. So we've taken care of this. Next, what does h tell us? H tells us the axis of symmetry for our upward or downward facing parabola. And so in this case, x is equal to not plus 3, but negative 3. And we've talked about this in the other lessons because it's x minus h. So if we put in h is negative 3, x minus negative 3 means we see it as x plus 3. And what can this plus 8 tell us? Well, this tells us the y value of the vertex. So x value of the vertex, y value of the vertex. So in this case, we know that the vertex, which has coordinates of hk, would have coordinates here of negative 3, positive 8. So there are 5 pieces of information that we can extract about a parabola when it is written in vertex form. Let's do a similar comparison for intercept form and reading it again sort of from left to right to examine all the pieces. In a similar fashion, the A value that's in front here can give us the same information as the A value does here. It can tell us if the parabola is upward or downward. It can tell us, based again if it's positive or negative, this one is downward facing, whereas this one was upward facing. It can tell us whether it is stretched or compressed in shape compared to our simplest parabola, which is y equals x squared. Since this A value is less than 1, we know that it is more compressed. It's going to be a wider parabola, if you will. So we've taken care of this piece. As we read across, what's the significance of this piece? Well, r is the value of one of the x-intercepts. So, in this case, there are 2 x-intercepts for this particular parabola. We have one where x is negative 7, and I've set this equal to 0 because this will equal 0. If this equals 0, then the whole right side equals 0, which ends up giving y a value of 0, which is a necessary condition for an x-intercept. And similarly, we would have x minus 5 is 0 or x is equal to 5. So the coordinates of the x-intercepts are negative 7, 0 and 5, 0. We would not write it as negative 7, 5. That's one point. These are 2 separate points. Okay. And so you can see that there are 3 things that we can pull out directly from an equation in intercept form. Two of them are the same as for Vertex, but then this is significantly different. Can we pull out anything else directly? No. Let's now go to indirectly. What can we find out about the parabola? We haven't talked specifically about this, but let's say I ask you, can you find the x-intercepts when it's in vertex form? The answer is yes, and we are going to learn about how to find out their values again in the next unit, but I'll give you a little bit of a preview into that. As I said over here, in order for a x-intercept to be determined, y has to be 0. So what if we were to set y equals 0 here and do a little bit of math? Let's set y equals 0 and see what happens. So I would have 0 equals 2 times x plus 3 quantity squared plus 8. And I want to solve for x. What's the value of x, like I solved for it over here? So using SAMDEB, or which is the opposite of bed mass, I want to peel away these layers. To get down to finding x, let's take this 8 away from both sides. So end up with negative 8 is 2 times x plus 3 quantity squared. Okay, let's next do the division by 2. So I have negative 4 is equal to x plus 3 quantity squared. Let's next do the square root. Square root of negative 4 is equal to x plus 3. So x would be equal to, taking this 3 away from both sides, the square root of negative 4 minus 3 is equal to x. Now, we run into a really big problem here, per se, in that it is not possible to take the square root of a negative number. There is no number that, when multiplied by itself, gives you a negative value. Okay? So it's not that this math is lost, it just simply means that because this isn't possible, this particular parabola has no x-intercepts. And it kind of makes sense, because if we think about how to draw this one, we would go over 3 and up 8 to get to the vertex. And, sorry, we would go over 3 this way, my bad. And it's upward facing, so it's never going to cross the x-axis. And that's cool. This is kind of useful. Not going to happen. So not all parabolas have an intercept form, but all parabolas do have a vertex form. Again, we'll look at that more in detail in the next unit. However, what if instead of this having been plus 8, what if it had been negative 8 instead? And I want to just play with that for a moment to show you what would happen before we leave this example. That means the vertex would be at negative 3, negative 8. So it would be down here somewhere. And we know it's upward facing and a little bit stretched. So we would expect that there should be 2 x-intercepts. Could the math tell us what they are? If this were changed to a negative 8, this would end up being changed to a positive 8 when I add 8 to both sides to get rid of it on the right. That would make this a positive 4. And we can do the square root of 4. Now from here you might go, well, how am I going to get 2 answers for this? Well, let's remember that the square root of 4 has 2 possible values. Okay? So x can be equal to the square root of 4 minus 3. One of the roots of 4 is 2. So x could have a value of negative 1. So one of these intercepts is at negative 1. But there's another value that root of 4 can have. The root of 4 can also have an answer of negative 2, because negative 2 times negative 2 is equal to positive 4 as well. So x could be negative 5. So that means one of these is at negative 1, 0, and the other one is at negative 5, 0. Now again, we don't need to know about this for the unit we're currently in, but it's a cool little precursor into the next unit, that it is possible to find the x-intercepts when you're in vertex form. It just takes a little bit of work. It's indirectly available through some extra little tasks. Okay, What about intercept form? Is there anything else that we can learn about the parabola indirectly? Well, we don't know the vertex yet or the axis of symmetry. But the axis of symmetry is easy to find because we remember that it is in the middle between the x-intercepts. So let's figure out where the middle of these two would be. Maybe we could add them together and divide by 2. So negative 7 plus 5 over 2 would be negative 2 over 2, which is equal to negative 1. So the axis of symmetry would be x equals negative 1. If we know that, we therefore know that the coordinates of the vertex are negative 1 something. How do we find that something? Well, we put that value of negative 1 into the equation to find that something. So negative 1 plus 7 means this would be 6. Negative 1 here minus 5 means this would be negative 6. Positive 6 times negative 6 would be negative 36 times negative a half. Negative times negative is positive, and half of 36 would be 18. Okay, so the vertex can be found just by subbing this x value into the equation. Okay, so we can find everything about a parabola in both forms. It's just this one gives us a little more up front than this one does. Let's look at just a couple more criteria comparatively between these two to conclude the unit. Our final two criteria are what information do you need to know in order to come up with its equation. Okay, so if I want to find an equation of a parabola, I have to know what goes in for A, H, and K when it's in vertex form, or A, R, and S when it's in intercept form. If I know all three of those things, bam, I have the equation. So in order to come up with the equation, I have to be given H and K, which are the coordinates of the vertex. To go here and here. But in order to find A, I also have to know one other point. On that parabola, other than the vertex. It could be an x-intercept, it could be a y-intercept, it could be any other point that's given to you. But you would have to be able to be given those in order to come up with the equation to solve for A. Okay, how would you solve for A? You would sub it in. You would sub in your other point, in for x and y, and you would solve in your values for h and k from the vertex, leaving only the a to be solved for, okay, and by rearranging it and solving it. If you want to find the equation for a parabola in intercept form, you have to be given the two intercepts. So you have to be given R0 and S0. And you need one other point. That other point could be the vertex, but it doesn't have to be. It could be a y-intercept. It could be any other point that's given to you. How would that help you find the a value and therefore come up with the equation? Well, again, same idea. You can sub in your r value and your s value into r and s respectively in the equation. And you can sub in your other point coordinates, put in the x coordinate in both places here and the y coordinate here. And then you would be left to rearrange and solve for a. And then you could come up with the equation for that particular parabola. So there's a great compare and contrast. We've now studied 2 of the 3 ways that you can see a quadratic equation. In our next unit, we will look at the 3rd one and we'll do a compare and contrast between all 3 of them.